Now that our model is aligned, we may want to try to further improve our alignment. To do so, we use the Refine button. Refine alignment basically analyzes the surface norms of your data and tries to lock in your alignment even tighter. Now that we've got our initial 360 scan fully aligned, we may want to get rid of some of the uninteresting data or stuff we do not need. To do so, we'll go to the Trim panel. First by clicking the Back button and going back to the main model panel, and then clicking the Trim button to bring us into the Trim panel. We are now in the Trim panel, and we have multiple ways to select the data we don't like. A circle selector, a square selector, and an expandable rectangle selector. Our last selector is the polyline selector. It will allow you to create a customizable shape to select your data, and it will actually update the selection process in real time. Notice the yellow box. I have gone ahead and selected all the rest of the data that we'd like to trim, but you'll notice at the bottom of the manifold there's a small area that's still of interest to us, and we don't want to get rid of this. So go ahead and select the minus selector. With my blue selector, I go ahead and highlight the area that I want to keep. That area is now deselected and will not be trimmed. To trim the rest of our data away, hit the Trim button in the upper right hand corner. Now that we have completed trimming on our first 360 scan, we notice that we're missing a few important parts of our model, like the top and some of the sides. To fix this, we can just add a few more scans. Go ahead and hit the green Scan button now. Now that we're back in the Scan panel, I can take some more scans to capture the areas that I was missing. I will reorient my object to capture the sides, top, and bottom of the scans which I missed previously. Using the same settings that I set before, I will scan this object, the only difference being auto alignment. Because we did a previous manual alignment, we can now use the auto align function. The auto alignment function uses our previously known turntable position to infer our alignment for our next object. Basically, because we didn't move the turntable within reference to the scanner, we will be able to automatically align our next set of scans. Our second 360 scan has finished and auto aligned. I will now align this 360 to our previously captured 360 scan to create our full model. This alignment is known as family alignment. Anytime we do a 360 scan or a bracket scan and align it to another family, it is known as family alignment. Family alignment requires 3 or more pins. In this case, I'm going to use 4 pins, which should be sufficient to align this data. Now that we've finished scanning and aligning our data, we can manipulate the model on our screen to make sure we like all of our data that we've captured. If I go to mesh mode and zoom in, you will notice we have lots of overlapping meshes. To get rid of this, we use a function called fuse. To locate the fuse button, go back to the main model panel, where it's located in the upper center of the screen. Fuse is a 3-step process. It combines your meshes, does some hole filling, and does a remesh for a clean, air-free export. To adjust your fuse parameters, click the Settings button here. The fuse settings are simple. We have the option to fill all holes, or if you don't want to fill all your holes, you can fill holes below a certain circumference. In this case, we'd fill all holes below 1 inches. We can adjust our texture blending, and we can adjust our resolution ratio. We typically suggest resolution ratios in the 0.6 to 0.9 inches range. The last thing you'll notice about the fuse panel is the Simplify slider, located here. Basically, the Simplify slider does a variable decimation on your model. This lowers your file size without drastically reducing the detail. So, let's go ahead and fuse now. Our fuse is now complete. If we zoom in on our newly captured family C, which is our fuse model, you will notice that we have one singular mesh. This mesh is a non-uniform one. It has been variably decimated. This is because the adjustment we made to the Simplify slider prior to fuse. Now that we've completed our mesh model, it's time to save it. Choose File, Save As. We have lots of file types to choose from, including our native SCN and NZIP, which zips our SCN files. We have PLY, which has per vertex color, OBJ, which has the option of texture, STL, VRML, which also can include texture, XYZ are points, U3D can include texture as well. IGES and STEP are mostly used for surfaced or NURB surface files. For this particular file, I'm going to choose STL. You'll also notice you have a few Save As options when you export a model. You can save the finished scans, which are the ones only in the green, and you have the option to save it as multiple files or as a single file. I'm going to save my finished scans and as a single file. I'll now name my mesh file and go ahead and save it. This completes our mesh model creation, and now you can bring your STL mesh into another CAD program and reverse engineer.